Now we're looking at the dorsal surface of the brain, and one of the things we should note here are the arachnoid granulations. These are parts of the arachnoidea that penetrate into the superior sagittal sinus. The cerebrospinal fluid that's surrounding the brain goes back into the venous system at this dorsal point, just lateral to the mid-sagittal sinus. We can see that in this brain the dura mater is missing, but the arachnoid is still in place. And we can see some of the places where the subarachnoid room is enlarged. Here at foramen magnum, we can see the way that the subarachnoid room is enlarged. Generally speaking, you can see cisterna of this type around the whole brain, but they're larger in some parts than others, particularly when one goes from one part of the brain to the other. Normally you see them at the base of the temporal lobes and around the mesencephalon. At this point we're going to start the three-dimensional dissection, and the very first step here is to make some horizontal cuts through the very top of the brain. And what we want to be careful about at this point is make sure we don't cut down to the level of the corpus callosum. So all of the time I'm trying to determine, either with my thumb or with some sort of an instrument, how far away the corpus callosum is from the cut that I'm making. At this point we can see the white matter, or centrum semiovale, which looks to be uniform in texture, but in reality it has a lot of directionality, some of the fiber systems in there, which we will see. Here I've cut down to the level of the ventricles, and I was lucky that this brain is a symmetrical brain so that you can see the ventricle system on both sides. So the next part of the dissection is to remove the cingulate gyrus but leave the corpus callosum in place. So here I am removing the cingulum, and we can see here the corpus callosum, which of course connects the two brains at the midline, and it is not really just a straight over connection. There is a certain amount of curling of the system once it gets to the other side, like this, so that what one sees in that white line there is actually the capsule interna and the corpus callosum together. So I want to finish removing the cingulate, but I also want to look into the ventricular system, because here I can see the plexus choroidea, so the choroid plexus sitting here, and to the left of that is the thalamus, and we're going to look at this part more carefully when I lift the corpus callosum up. Here we have the caudate nucleus lying in the lateral part. So here I remove the rest of the cingulum, so we can now see the corpus callosum, and I'm going to make a very special sort of triangular cut down into the region of the lateral ventricle here, where the inferior and the basis of the ventricle system meet each other, the so-called trigone. And I want to do that because I ultimately want to look down inside of the inferior horn of the ventricular system so that I can follow it in this dissection. Because essentially what it amounts to is me putting my knife in the lateral wall of the inferior horn and cutting down as far as the ventricular system goes. So here I'm putting my pinceps down inside there. That's the direction I want to go. And essentially it's a cut that's going to be through the lateral surface of the temporal lobe. So here I put my knife into the lateral ventricle at that trigonal area, and I cut down, keeping my eye all the time on the lateral ventricle, because I want to make sure I'm in the wall of the lateral ventricle and not deeper in, for example, the hippocampus, which is coming into view here. There's a slight artifact that you can see on the surface of the hippocampus. And I've cut down all the way to the rostral part of the inferior horn, and now I'm going to cut through the amygdala so that the whole temporal lobe now is separate. I'll do that course on the other side, cut down on a line that goes through the lateral side of the temporal lobe, holding my eye all the time and the edge of my knife at the edge of the inferior horn of the lateral ventricle. And again, I will cut up rostrally and go deeper and cut through the amygdala so that the inferior part of the temporal lobe can be separated from the rest of the brain. Here I'm now looking into that inferior part of the lateral ventricle, so you can see that it's lying sort of in the same plane that I made my knife cut. Now I want to open up the anterior part of the ventricle system, and that went very fast, I realize, but it's simply following the roof of the anterior horn, as you see here, so that I can now look down inside at the ventricle system and look at the interventricular foramen here, where I have my knife right now. And we want to know where that is because in the next part of the dissection we're going to make a cut from the interventricular foramen rostrally through the septum pellucidum and through the genu, or the knee of the corpus callosum. This you can see here. I put my knife in the interventricular foramen, cut rostrally through the septum pellucidum and through the genu of the corpus callosum. Now I can see here the fornix, and I'm going to try to keep the fornix on the upper part of the dissection here that I have my left hand on. So I'm being careful here to try to maintain the telechoroidea. So I'm lifting up the fornix. You can see the fornix here. It's underneath the corpus callosum. And what I have underneath this is the foramen interventricular, where I just had my pincette, and the telechoroidea. The telechoroidea is very difficult to understand at first because it's an invagination of the inferior part of the arachnoidea that essentially forms a blind pocket lying on top of the thalamus. You can see the internal cerebral veins. I'm trying to show you with my finger how that telechoroidea is actually formed. Imagine my finger coming in from underneath the splenium of the corpus callosum. So I've actually split this preparation at the fissura choroidea, which is that line between the telechoroidea lying on top of the thalamus here and the edge of the telechoroidea, which is the plexus choroideus. So the important point to realize here is that I'm going to cut this over because it's both attached to the corpus callosum and to the mesencephalon, and I wanted to show you how I can now take the inferior part of the temporal lobe, and after I've freed it completely from the rest of the brain, I can now remove it or move it up dorsally. So here you can see the hippocampus and the floor of the fourth ventricle lateral to it. So I'm going to do the same thing on the other side. You can see where my cut has been now here. It's through the lateral surface of the temporal lobe. I'm going to do the same thing on the other side. Cut all the way deep in through the amygdala and remove this inferior part of the temporal lobe with the hippocampus from the rest of the brain. So now I'm going to focus a little bit more on this part of the brain that we've now removed. Here we can see the circular form of the fornix, hippocampus, and the fibers coming out of it. The fornix makes almost a circle and goes down into the columnar fornices, which are in reality on the other half of the brain. Here we can see the amygdala, this darker region just rostral embedded in the white substance, whereas this is the hippocampus proper. Here with the uncus, and here is the amygdala. Of course, it's more complex. It's not a uniform structure. It has a number of nuclei within it. Now I get a little bit larger picture of this. I can see this circular form that the hippocampus and the fornix make. So I've essentially cut over the fornix here where I just pointed. That is, those are the columnar fornices. And just behind that is the foramen interventricular. Now we can see the telechoroidea with its lateral specialization as the plexus choroideus. Inside of this pocket is the internal cerebral veins, which you can see have been cut over. And the important point to realize is that the telechoroidea itself is forming the roof of the third ventricle, whereas the lateral part of it is pushed out through the fissura choroidea, or the choroid fissure, and is in the lateral ventricle. And I'll try to demonstrate this a little bit better here. We have plexus choroideus, one of the choroidal arteries that you can see there. And if I put this back, the point is that I want to make here is that when I have the fornix and the corpus callosum on top of the telechoroidea, it's only the choroid plexus, or the lateral part of the telechoroidea, that's pushed in through the choroidal fissure into the lateral ventricle. So here we see on the right the fornix on one side of plexus choroideus and the thalamus on the other. Of course, the plexus choroideus goes all the way down into the inferior horn of the lateral ventricle. So what we're looking at here, that major cut in the middle, is really an artifact. Here is the septum pellucidum that we cut through. So I cut by putting the knife into the foramen interventricular, or the interventricular foramen, and I drew the knife rostrally through the genu of the corpus callosum. So here you can see the cut part of the genu of the corpus callosum. And when I lift that up, what you can see here is the septum pellucidum. Again, the major cut that you see there is actually an artifact. Septum pellucidum is much thinner, and we can see it a little bit better here. It is just sitting to the right of that artifact. So here is the caudate nucleus. We can see the head of it and its tail going around, sweeping around, much like we saw with the form of the hippocampus and its fibers, the fornix. And if we look more carefully now, we can also see where we had cut over the telechoroidea. We can see the mesencephalon with the superior colliculus, and just below that the inferior colliculus. So at this point we're going to make a dissection of the cerebellar peduncles, and one of the things we want to do is to make a blunt dissection of the anterior part of the cerebellum, so that we're going to grab a major part of the anterior lobe and see if we can separate this from the rest of the cerebellum and see some of the structure that's lying beneath it. And what we can see is the two major peduncles, the superior peduncle, which is sitting just lateral. First we have the colliculus superior, colliculus inferior. That was the fourth nerve, which we weren't able to see when we were looking at the cranial nerves on the front side, or the basal part of the brain. Here we can see the superior cerebellar peduncle, and just between the two of them we find a part of the cerebellum, the vermal part of the cerebellum, lying here in between the two superior peduncles. Now I'm going to place my knife in such a way that I can cut parallel to the surface of the superior peduncle, and then I can identify the nucleus dentatus, which is sitting deep inside of the cerebellum, and we can see the fibers coming out of it, going up through the superior cerebellar peduncle up to the thalamus. Again, we can see the vermis in the midline, still part of the cerebellum that remains there. And if I do the same thing on the right side of the cerebellum, that is to make the same cut, then we can see the beautiful symmetry of the brain here with the dentate nucleus on the two sides of the cerebellum, each one feeding up to the ventrolateral thalamus and eventually up to cortex. So this is the major output of the cerebellum we're looking at. The other deep nuclei are relatively difficult to see. If I now go to the basal surface of the brain, I'm going to make a dissection of the two other cerebral peduncles, the inferior and the middle cerebellar peduncle. So in order to do this, I have to remove the so-called tonsillar region of the posterior lobe of the cerebellum. But I want to go back now to this part of the dissection where we're looking for the inferior cerebellar peduncle. So we're looking back into this region here. Here is the opening of the into the fourth ventricle. We're looking in this from the caudal perspective, and we're looking at this angle between the pons and the cerebellum, and there I can see the flocculus, the oldest part of the cerebellum, and it's connected to the nodulus at the midline through this fiber system that you see there very much in white. I can also remove part of the eighth cranial nerve. That's part of the cochlear nerve that goes over the inferior cerebellar peduncle, goes to the dorsal cochlear nucleus, and here you can see I'm separating out a fiber system that's coming from the spinal cord and going up into the cerebellum, which I otherwise couldn't have seen because the flocculus and its stalk are sort of covering over it. Here we can still see the inferior cerebellar peduncle, and I can separate it from the middle cerebellar peduncle. Here we have the inferior, and here we have the middle cerebellar peduncle. Again, the middle cerebellar peduncle here, and the superior peduncle beside it. So in order to see the inferior cerebellar peduncle, it's been necessary for me to take flocculus and move it medial so that the stalk that's overlying the inferior peduncle is exposed. Now we're going to take a closer look at the insular region. I'm going to show you exactly where we're going to be looking, putting back the brain together again, so that you can see that we've cut through the lateral part of the temporal lobe, but I'm now going to go into the sylvian fissure and remove the middle cerebral artery and the arachnoid membrane that's lying over that. If I can now look deep into the lateral fissure, I can see the bulk of the middle cerebral artery, and I'm going to remove that so that I can now look into the deep part and see the insula deep down inside the lateral fissure. Now I'm going to make another blunt dissection here by simply pulling parts of the opercular region, which are the so-called lips that are surrounding or covering over the insular region. And when we do that, we can already see that there's a certain amount of structure in the white substance here. We can actually see part of the fibers that go from gyrus to gyrus. We can also see some of the fibers that go from one lobe to the other. And in parts of this we can also see the projection fibers, for example, part of the internal capsule that I'm pointing to there. So the internal capsule is sort of like a fan-form structure that is medial to all of this which we see here now. So it's the deepest part of the white matter. I can try to remove some of the more superficial parts of the white matter here, because we had, of course, gyrus to gyrus, then we have lobe to lobe, and then we go deeper. We'll be able to see the internal capsule in which fibers are passing both in and outside, and if that, you can see in that region here that it's a more radial orientation that we see in this part of it, because we're down now to the deepest layer of the white matter, the so-called internal capsule. Now when I remove the insular cortex, which I'm doing here, we get down to a number of thin layers that separate the insular cortex from the lentiform nucleus, which is lying deep inside of here. At the bottom here we can still see some of the association fibers connecting the frontal and occipital lobes. And then we can also see a curving structure here, the so-called fasciculus uncinnatus, which connects the frontal lobe with the temporal lobe. So both of them are sort of fused together here, although one goes from frontal to occipital, the other goes frontal down to temporal lobe. So what I'm going to do now is try to remove some of these external layers that are layers that lie external to the lentiform nucleus. Here I can see once again the inferior fronto-occipital associations fiber and part of the uncinate fasciculus. But what I'm going to do now is to try to remove some of these external layers, or layers that lie external to the putamen, which we can now see here as the dark structure within. So what I'm removing here now is the external capsule and the extreme capsule and the claustrum, which we'll see later in the dissection. We can also see the radiating fibers of the internal capsule. Now I'm going to put this together again, and we're going to look at this more carefully to see the ventricular system, which we've essentially opened up laterally or dorsally around its entire extent. And we can see the capsule interna, or the internal capsule, which is important for us to understand. Then we're going to move to the other side of the brain, and we're going to do the same thing here, at least in the start. That is to say, we're going to remove the arachnoidea and the middle cerebral artery from the right side of the brain, and then we're going to make a blunt dissection again here by removing some of the more superficial opercular region around the insular cortex. But in this case, rather than remove the layers of the insular region from the lateral side, here we're going to cut through this in a frontal section so you can see the cross-section of this more classical appearance of the nucleus lentiformis. So in this preparation, when we look a little bit closer at it, we'll be able to see some of the subdivisions here. Most lateral, we see the cortex and then the capsula externa claustrum, and then we come into the putamen. And more medial, we have the globus pallidus, which it is possible to see some subdivision if you look very carefully into the external and internal components of the globus pallidus. Well, I hope you enjoyed that, perhaps learned something.